Pre-algebra, lesson 4, multiplication, and division patterns. So this will be very similar to lesson number 3. I'm going to give you more of a concept for multiplication and division. I ask that you memorize the key words on your own, those key words being factor, product, quotient, dividend, and divisor. Ooh, can't believe I forgot the word divisor. So those are the key words that you need to memorize on your own. Of those keywords, the main ones that are definitely going to be known for tests are product and quotient. Product is the answer to a multiplication problem. Quotient is the answer to a division problem. I'm going to teach these conceptually so that way we can kind of understand them. And then to understand them conceptually, we have to understand multiplication is also not only a faster form of addition, as we see here. We see 7 added up 12 times, which is the same as 7 times 12. We have to understand that multiplication, like 7 times 12, is another form of area, or a geometric problem. So for example, if I were to take a rectangle with a side of 7 and a side of 12, the area would be equal to 84 square units. But we see here the multiplication, 7 times 12 equals 84. So the way I break this down is the pattern for multiplication is length times width equals area. Okay, and then likewise the pattern for division will be the opposite, or area divided by length equals width, or if we were to switch it, area divided by width equals length. Right, and we can see all of that with this example square, the 5 times 10. Right, so if I were to do all of these and I did length times width equals area, if I did 5 times 10, I get 50, or the area. Right, if I did the area of 50 and I divided it by the length of 10, I get the width of 5. Right? If I do 50 divided by the width of 5, I get the length of 10. Right? So that's how we see that multiplication and division are inverse operations because they counteract each other. And then this is the pattern I want you to know. And always, always, if possible, relate your multiplication and division to an area problem. Right? So length times width equals area, and then area divided by length equals width, or area divided by width equals length, or they undo each other. Right? Now, let's take these concepts, and again, I'm going to skip the first half of the lesson where they talk about the algorithms for multiplication and division, because those are things that you should already know from last year, and it mostly has to do with lining up place value and remembering the rules for the multiplication division algorithms. If you have a problem on that, let me know, and I can help you out extra on the side. But let's focus on the meat of the lesson, which is how do we find the missing parts in a multiplication or division problem. All right? So here, in example 4.5 in your textbook, let's see here, and we have 12 times n equals 168. So if we think of this as an area problem, we have length times width equals area. So if I need to find the missing length, right, so let's draw this out. If I have a side of 12, a missing side of n, and then an area of 168, in order to find that missing side, I need to divide, right? Or if we can see here, if we need to find a missing side, the answer is to divide the area by one of the sides, right? If we need to find the area, then we need to multiply, okay? So here, in this problem, we are given the area, which is 168. We need to find one of the sides. So we're going to take 168 divided by 12 using our good old-fashioned division algorithm. I understand some of you may not have learned how to divide using this particular algorithm. If you learned a different way, please let me know so I can help you fine-tune this way, because this is a necessary skill for algebra as you get into division of polynomials. Right? But that's a side fact. Let's see here. 12 goes into 16 one time. 1 times 12 is 12. And 16 minus 12 is 4. Bring down the 8. 12 goes into 48 4 times. 4 times 12 is 48. Subtract, zeros out, and my final answer is 14. So n is equal to 14. I can put a box around that, and I'm done with that one. Let's go on to the next example. Alright, so the next example is a division problem. And we have the problem b divided by 3 equals 15. in this problem, can we guess where the area would be? Well, if it's division, then the area is being divided to find the length and the width, right? So these are the lengths and the widths of our rectangle. If I were to draw this out, and I see 3 and 15, and I'm looking for the area, it's very simple. All I have to do is multiply, and I can get the right answer. All right, so that's why it's such a great way to visualize it that way. So if I take 15 times 3, 3 times 5 is 15, 3 times 1 is 3, plus the 1 is 45. So the answer is 45. B is equal to 45. All right, so that one's pretty simple. Let's look at the next one. The next one says 64 over a equals 4. This can be a little tough if you don't remember one of my primary rules when it comes to thinking about fractions, which is fractions are the same operation as division. So when you see a fraction, especially in your pre-algebra textbook, sometimes it's helpful to reread that fraction as a division problem. So if I were to read this as a division, it would be 64 divided by a. And in this case, it even helps to write it that way. So if I rewrite this problem as 64 divided by a equals 4, I can see what's happening. I have the area divided by a length to equal the width, or the width to equal the length. So 64 divided by part equals part. Okay, so if I were to draw this as a area problem, the area would be 64, one side would be 4, and to find the length a, I would have to divide. So let's take a division algorithm. We'll take 4 and do 64. 4 goes into 6 one time. 1 times 4 is 4. 6 minus 4 is 2. Bring down the 4. 4 goes into 24 6 times. 6 times 4 is 24. Subtract. I get 0, and we're done. So the final answer is A equals 16. All right, that's it for this lesson. If you have any questions, let me know on the school website, and I will see you in the next video.